Hello everyone, welcome back to my channel. In this tutorial, we are going to see the complete process of making the dose response curve and how to calculate the IC50 value. So we will start from the absorbance value. We will get the absorbance value of 570 and 630 nanometer, and then we will calculate the percent cell viability, standard deviation, percent RSD, and standard error of mean. Now this all statistical data we will use to plot using the GraphPad Prism. So we will plot the hills plot, that is the sigmoidal plot, and also we will make the bar plot. So we are going to go through complete process of data analysis to graph preparation ready for the publication. So let's start. So in the first step, we will do the complete statistical analysis. So we have two data sets of the 96 well plate. First is the absorbance value as at the 570 nanometer, and the second is the absorbance value at the 630 nanometer. So these are our control. So I am highlighting the control as the gray. So first what we will do, we will do the 570 minus 630. So I will copy paste equal to this minus this cell, then I will enter. So this is the value of 570 minus 630. Then I will drag up to 12th well, then I will drag completely. So this is the completely 96 well plate, 570 minus 630 value, and this I am highlighting because this is the control. Now we got our values. Now let's first calculate our uh, constants. So first we have control. So I am going to take the average of the control. So I will use the function average, and I will take 6 value. So for all the concentration, we are going to analyze at n equal to 6. So this is our control average. Now let's make the uh, percent cell. Let's calculate the percent cell viability with respect to our control. Okay, so again I will copy paste cells. Now this is our control, so with respect to that we have to calculate. So equal to this particular specific cell divided by our control multiply by 100. So now we have to use control in every cell, so we will make it constant. So I will apply the dollar sign. Okay, so this is the with respect to controls, it is the 98% value. So its viability with respect to control is 98%. Now I will drag up to 12th well, then I will drag completely. So now we have the percent cell viability of each well with respect to average control. Now let's make the table. So I will copy paste the heading which I have already prepared. So the concentration what I use in the analysis is this one. Right. Now let's make the average of these 6 wells. So this is the n equal to 6. Now this well up to H, it is 80 micromolar. Okay, after that let's start from here and let's drag till the end control. So this is the control. So control will always come as 100 because With respect to control, we have calculated that one, so it will obviously will come to 100. Now let's make it up to 4 digit. Now let's calculate the standard deviation. So equal to the standard deviation sample. Then again select the data set. Standard deviation sample. Okay, so this is we calculated. Again cross check. Okay, this is that cell, this is that row. Okay, now let's calculate the percent RSD. So percent formula for percent RSD is equal to the standard deviation divided by the average multiplied by 100. Let's check. So this is our percent RSD. Now let's get the calculate the value of count. So count will come for all like concentration, it will come n equal to 6. So count up to 80. So now we have count as well. So sample size. Now let's calculate the standard error of mean. So formula for the standard error of mean is the standard deviation divided by square root of n, square root of sample size, square root of n. So square root of sample size. So this is the standard error of mean. So our statistical table is ready. So this statistical table we are going to use for the analysis and our graph presentation. So that till this you can do in the Excel. So you can get the concentration, percent cell viability, standard deviation, percent RSD, your sample size, and a standard error of mean. So what here I would like to highlight one point: if your percent RSD is less than 10%, then your data is very good, so acceptable, right? So now we will go to GraphPad Prism. So I will delete all this which I have previously prepared. So I will start from the fresh. So I will delete all sheets. Okay, so what you have to do, you have to first click the new data table. Okay, so it will ask like create. So we have to choose XY plot. So here we have an option what will be on x-axis. X-axis will be number. What will be on y-axis? Y-axis will be the our mean, the standard error of mean, and the sample size which we have calculated in the Excel. So create. Now we will copy paste the data from Excel. So first we have to copy paste the concentration. So this is our concentration. This will be percent cell viability. Okay, now let's go first copy paste percent cell viability, then standard error of mean, then sample size. Okay, so now this data table we will rename as Hills plot or Sigmoidal plot. right? And I'm making the duplicate of this so that we will use for the histogram. So I will rename as histogram. Okay, so let's first do with the hills plot. So in that, first we have to change our x-axis in the log form. So you have to go to analyze, then you have to click the transform, then OK, then you have to use transform x value using log x equal to log x. Okay, so this will give you the transformed data. So transformed data will be here. Okay, now we have transformed data where concentration has been changed in the log form. Okay, now again we will do the analyze. Now we will apply the non-linear regression and the curve fitting. Okay, then since as the dose concentration is increasing and the percent viability is decreasing, so we will use the dose response inhibition option. Dose response inhibition option, since we are using the log inhibition versus response, we will use this option, second option. Okay, okay, so now we will get the result. Here we will get the best fit value, we will get our IC50 value, we will get the R square value. So we will see these all things one by one. So what here we will get in the graphs, we have to see this one. Okay, now we have to do slightly adjustment since our graph is start from 1 because our first concentration was the 10 micromolar. We will do the slight change. So here you have to double click on the x-axis to open its editing window. So now I want to start our x-axis from 1. Okay, so I will put 1, I will apply. Okay, so it graphs start from the 1. Okay, now let's do some editing. So we have percent cell viability. Let's change its name because it is the log concentration. Log concentration. Right, now let's change its font. So to change its fonts, you have to go in a title and fonts x-axis. So x-axis I generally use this one, light 12. Okay, same applies for the y-axis, this one light 12. Okay, now apply. Okay, you can see now same for this one. For the title you can change from here, Arial. I'm going to use the same one. Right, that is done. I will keep it as a bold because it is the axis title. Right, now let's slightly make this one axis thickness slightly lighter because to match our font. So here you have to go in the frame and origin. By default it is 1 point. I'm going to use 1.5. Apply. Okay, so now you can see the very symmetrical good looking graph. Now let's change the color. So you have to double click here. Okay, here you have to choose the right data set. We are doing on the transform of hills plot, so you have to choose transform of hills plot. So here suppose I'm choosing this color. Okay, rest it will automatically choose the bars color accordingly. Okay, fine, apply. Okay, so it is color in change. I will change the title hills plot. Okay, now let's put the parameters. So I want to put here in the graph IC50 value and R square value. So here on the graph you have to click the right click, then insert information or analysis constant. This will open the new window of the constant. You have to go in here, right, parameters IC50, estimated IC50. Okay, so this comes then you have to write IC50. Yeah, right. You can put where you want to put. Then let's put the R square value. Okay, goodness of the feed R square. Okay, R square. So other parameters also you can put as per your requirement. Okay, so now this is our dose response curve. We calculated our IC50 and R square, and this is the publication ready graph. Now let's prepare the bar graph. Like some publication uses the bar graph. Okay, so let's use this data table. Now here we will put the one option, right? Because here we are going to use control, right? So let's put control, because control is our 100%. Copy, paste, right? Now let's take the controls value. This will always be 100. Let's take a standard error of mean for control, and n is obviously 6. So now we have data set for the creating the histogram. Now what you have to do, you have to again go to analyze. Now here, sorry, we have to change the format, not XY but grouped, right? Okay, now we have to insert new graph of existing data, right? So our table is histogram, and we have to group this one, first one, mean with standard error. Okay, so now we have created our histogram. Okay, now let's put percent cell viability, right? Y-axis is the concentration. This is not concentration, this is the simple concentration, right? This we do not need, right? This is the histogram. Okay, we will keep histogram. Now let's apply the same treatment here also. Title, we will use this font, light 12. Okay, this font, light 12. Okay, right, apply. Okay, so this one is changed. Let's change the frame. So frame points half point. Okay, now let's change the color. So we can click here, histogram, change the right. Okay, let's choose this one. Let's choose the border color, this one. Border point I will put 1/4. Apply. Okay, so now we have the histogram of the same data. So now let's put in the layout. So here if you go, there is the one last option is layout. Let's start with a new layout. I want to put side by side, so 2 array of graph 2 across 1. Okay, so now this will open the this option. Now I will double click here, so it will give me the options. So first I will put the hills plot. Okay, then I will put this one, bar graph. So now here, now you can see that both x-axis is not aligned. So what you can do, just select this one, okay, align x-axis, and again you can see the slightly its y-axis is larger than me. So what you can do, equalize factors, right, and then align x-axis. Now both x-axis is aligned, y-axis is also there, so both graph looks symmetrical. Okay, so suppose this is the concentration I want to put somewhat higher. So what I have to do, I cannot change in the layout. I have to go to histogram. I have to manually do right here. Now what you can do here, you have this one. Now if you want to send for this one for the publication, you have to take in the right image format. So export, suppose I'm taking the JPEG format. JPG format. Here you can apply as per the journal's requirement, suppose 300 dpi, whatever. There are several options are there. Suppose file name I'm putting MTT graphs and saving on the desktop. So in the desktop, if I see, this is the image. Okay, you can see now you can transfer this image in the PPT or directly into your manuscript. So this was the all about of preparing from your raw data of 96 well-played absorbance data to apply the statistics and get the all the values like percent cell viability, standard deviation, percent RSD, standard error of mean, and making the graph from that. You can make the both sigmoidal graph, histogram. Mostly these two are acceptable by most of the publication. Thank you.